Hi folks, today we're going to talk about exponential growth functions and translations with them. Remember, to translate means to shift, and anytime you're shifting, you're adding or subtracting numbers in the equation. Now, where you're adding or subtracting numbers determines if you're shifting horizontally, side to side, or if you're shifting vertically, up and down. So remember that x is the side to side axis. So anything that's in there with x, so x minus a number or x plus a number, that's going to shift horizontally. It's going to be in parentheses, and anything in parentheses is a lie. So in the exponential function, we have x as the exponent. So if I put parentheses around this, anything inside that's plus or minus a number is going to shift things horizontally. Now, with growth functions, we have b values to worry about. So the b value is the base, what's being raised to the exponent. So our base could be 2 or 3 or 4, basically anything more than 1 that would make exponential growth, because a b value greater than 1 would be exponential growth. Now I want to show you where those end up on the graph, but first I want to talk about what all three graphs have in common, no matter what the b value is. So notice that all three graphs intersect the point 0, 1. And they intersect the point 0, 1 because that's always going to be the y-intercept unless you do some translations. So the y-intercept will be 0, 1. The domain will be all real numbers from arrow to arrow. The range is anything greater than the asymptote. Now notice that the horizontal asymptote is down here. It's not really drawn in, but we can draw it in. And you'll notice that it's kind of hard to draw in and really see it on camera. You might be able to see it better on yours, but it's kind of hard to see it. And so you'll notice later on that some of the asymptotes kind of look like they're below where they're supposed to be. Just know that they're actually supposed to be along that horizontal line. Okay, they're just kind of shown below so that you can see them. So the point 0, 1 will be there unless we are shifting. The b value can be identified by going over 1 and figuring out how many you go up. So this distance right here, that's the b value. When you go over 1, this distance right here, that's the b value. When you go over 1, this distance right here, that's the b value. So notice that here, this is 2 units, so b is 2, that's the base 2. Here b is 1, 2, 3 units, that's the base 3. And then here b is 1, 2, 3, 4 units, that's the base 4. And notice that the graphs kind of start curving up a little bit more sharply, especially from the first graph to the second graph. It curves up much more sharply, and so a larger b value will do that. It will make the growth happen faster. So let me tell you what it is that we're looking for. We're looking for this point right here. So we're looking for a nice pretty point, and we're looking for where the graph flattens out. So we're always going to have that kind of relationship. And then if I go 1 over to the right, I'm looking for this distance. That's what I'm looking for in every graph. I want to find the horizontal asymptote. I want to find that point right here. That's going to help us figure out where the transformation goes, how much it is. And then I want that b value, okay, on every graph. Whoops. Here, and then that distance on every graph. So let's talk about specifically horizontal translations. Horizontal translations, again, occur along the horizontal axis. That would be the x-axis. So the plus number or minus number is in there with is in there with x, up in the exponent. And remember that anything in parentheses is a lie. So if you have minus a number, that moves to the right. If you have plus a number, that moves the parent function to the left. So let's look at the examples. It says write the equation of each transformation. So I'm looking for the asymptote. It starts to flatten out right here. I'm looking for that point that's just 1 up. So it should be here, but it's actually over here this time. And then I'm looking for that distance, the next unit over. I'm looking for that distance. So that's what I'm looking for. Now, when I fill in these pieces, I need to fill in the pieces based on the parent function and where it's moved. Sorry, my camera stopped working. So what I'm trying to do is figure out this point that's always on the parent function, no matter what the b value is, this point 0, 1, where did it go? So that's what I'm trying to determine, is where did it go? So I'm going to go graph it on my example 1a. It's right here. And where did it go? Well, it moved over here. That means that I have shifted to the right 1, 2, 3. Shifted to the right 3 values. So that means that my h value, how much I shift, was 3. Now I know that whenever we put our h values in, everything in parentheses is a lie. However, the h value is actually 3. So when I put it in and I subtract 3, that's what makes it look like a lie. Now the b value is what comes next. So the b value is this next piece. What's this distance right here? So that distance is your b value, and it looks like this b value is 1, 2. So I'm going to put a 2. The horizontal asymptote right here is going through a y value of 0, just like in the parent function. And if I were to write the function with all of the pieces, I would be looking at this, and I would say f of x equals b, which is 2, to the power of x minus h, so that would be x minus 3. And then that would be it. So now let's look at the next graph. I'm going to go ahead and find the asymptote, which is going through the x-axis. That's y equals 0. I'm going to go find where this point moved to. Well, it looks like it moved over here. So that's shifting to the left 1, 2, 3, 4 times. So my h value is negative 4 because I'm shifting to the left 4 times. And then if I go 1 over and I figure out this distance right here, that's going to be my b value. So it looks like b is 1, 2, 3. 3. So when I write the function, I have f of x equals my base, which is b of 3, and then raised to the power of x plus h. So if I'm moving to the left, I've got minus 4, so this is x plus 4. All right. And I think this is a little bit of a misleading thing. This is just the number here. The h value is here. And you're always putting in x minus this number. So this really should be x minus h when h is less than 0. So when it's negative, it moves to the left. So just keep that in mind. If you were wondering why I put x plus 4 instead of x plus negative 4, that's because this should have been x minus h right here. And then the h value is just negative. So minus a negative makes the plus sign. So let's go to the next part of the notes. Vertical translation. So this time we're moving up and down. And remember, when you move up and down, that means that you're adding or subtracting a number outside of the parentheses. So we've got plus a number, moves it up, minus a number, moves it down, but really this should be plus k with k less than 0. So you're always adding the k value, but whenever you move down, the k value is a negative number. So let's go find those pieces. Let's go find the horizontal asymptote. This time it's going through right here. That went through a y value of 4. So y equals 4. Notice that the dashed line underneath is a little under where the asymptote should be. That's just so that you can see it. It's really at y equals 4. I'm going to go find that point. So it should be here. But it looks like the nice pretty point has moved here. So that's up 1, 2, 3, 4. And then if I go look at 1 over, that distance right here, that's my b value. Looks like my b value is 1, 2 units. So when I put everything together, I'll have f of x equals b, which is 2, to the power of x, because there's no horizontal transformations, h is 0, and then plus 4. That will move up. So what I'd like you to do is pause your video and try this problem. Try to identify the asymptote, try to identify where that 0.01 moved to, what the k value is, and then try to write your function. Pause your video. So the horizontal asymptote is going through a y value of -5. That 0.01 has been shifted down 5 units, so k is -5. If I go 1 over, that distance right there from the asymptote to the graph is 3. That's the b value. So here is the function. So let's write the equation of this translated exponential function in example 3. And it adds the domain and the range, and that's okay. We can totally do that. But we might have some shifting vertically and horizontally. So let's pay attention to the horizontal asymptote first. So it kind of flattens out right here. That's going through 1. So y equals 1. That point that should be at 0, 1, I need to find it. So go look for the nice pretty point. So there's a nice point right here. That's a shift to the right, 1, 2, 3. So h is 3. That's a shift up 1. So k is 1. And then the next value that I need is 1 over that distance. And so that distance right here is my b value. That looks like 2. So I'm going to write my function. F of x equals my base of 2 to the power of x with the opposite of h, and then plus k. The domain from arrow to arrow is all real numbers. However, the range is everything above the horizontal asymptote, and that's 1. So all my y values greater than 1, everything that is above 1. All right, we have 3 more problems. We'll try 4 together, and then 5 you can pause your video and try. So on number 4, I find where the graph flattens out. The asymptote is at y equals -5. I go find where my point of 0, 1 moved to, so I go find the nice pretty point right there. The graph has moved to the left 1, so h is -1. The graph has moved down 1, 2, 3, 4, 5, so k is -5. That next 1 over, that distance from the asymptote to the graph, that's my b value. It's quite a large b value this time. 1, 2, 3, 4. b equals 4. So I'm going to write the function. F of x equals my base b of 4 to the power of x with the opposite of h. So that would be plus 1. And then plus k, so plus a -5. The domain of all exponential functions is all real numbers. The range is everything above this asymptote of -5, so y is greater than -5. So what I'd like for you to do is pause your video and try number 5. So number 5, the horizontal asymptote is going through y equals -6. My 0, 1 has moved all the way down here, so that's over 2, so h is 2, and down 6, so k is -6. If I go 1 over, that distance from the asymptote to the exponential function is 3, so b is 3. The function is f of x equals a base 3 to the power of x with the opposite of h, so minus 2, and then plus k, so plus negative 6. The domain is all real numbers for all exponential functions, and the range is everything above the horizontal asymptote, so y's are greater than negative 6. Last problem today is a word problem. A piece of gold jewelry was worth $700 in the year 1980, and it has increased, so that's growth, in value over time by 1.8%. Well, if I moved this back 2 times and filled in the place with the 0, that means that R would be 0.018. That's my rate as a decimal. What will it be worth in the year 2020? So from 1980 to 2020, if I subtract, I'll find that the number of years is 40. So I want to go ahead and create my equation. My initial value of the piece of gold jewelry was $700. My growth rate is 1 plus R, so 1 plus 0.018. So that's 1.018. See? X is time, and the time is over 40 years. So if we were to graph this, we might be able to pick out some key features. But for right now, we're going to end here and use this as a review of writing the applications of exponential growth problems. So today, you learned that on the parent function, 0, 1 is always the y-intercept. No matter what the base value is, you go find the horizontal asymptote and that new point, and that's how you determine if the graph shifts left or right, up or down, and by how many. The next point over shows you how high, and that's the b value, and then you can insert everything into the function.